So in this lesson we are going to look at trigonometric ratios, and basically trigonometric ratios are used again with right angle triangles, and they're using right angle triangles, and they can be used to find an angle or the length of a side. Okay, so for example, they can be used to find out like this angle or this angle, or they can be used to work out the length of a side as well. So just something to remember in relation to this is this idea of the hypotenuse, the opposite, and the adjacent. So again, the hypotenuse is always the longer side, so it's always this longer side. The opposite is dependent on the angle that you're working on. The opposite side is the opposite side to the angle that you're working with, and we'll look at some examples of that. And then the adjacent is going to be adjacent to the angle that you're working with. So something that's important is like a little poem to remember some important formulas when it comes to trigonometric ratios is this here. So could a hungry stupid ostrich have taken over America? So what that represents is that, so we can say, so could, so it's C is equal to A hungry, okay, so it's A over H, stupid, so it's S is equal to O over H, have taken over America. So taken then is T is equal to O over A. And what this represents is, so this C here represents, let me just change this a little bit. This C represents cos, so COS. So it's the cos of the angle, and I'll just put in this symbol here for angle, so this just means an angle. This S here means sine of the angle, so sine, and then you have the angle. Okay, and then this T here represents the tan of the angle, T-A-N of the angle. And this letter here is just used to represent an angle. So A obviously stands for adjacent, H stands for hypotenuse, O is opposite, H is hypotenuse, O is opposite, and then H is, or A is adjacent. So this is, these here are the formulas that you use when you are working with these trigonometric ratios. So let's look at a kind of question that you could be asked in relation to this. So let's say they'll give you a right angle triangle. So again, remember, right angle triangle, one of the angles will always be 90 degrees. So they might do something like this. So they might say, for example, they might say that so this side is 11. They might say that this side, let's say, is so let's say they might give us an angle. So for example, this is our angle, and they might say it's 67 degrees. Okay, and then they might have this unknown, let's say here, which is x. And they might ask you to work out, so in this case we're trying to work out a length. So remember, it can be used to look at a length, or it can be used to calculate an angle. So in this case we're being asked to work out the length, so this length here. So the first thing you want to do is you want to look at your triangle, and that has all of the lengths and angles in it, and you want to identify what you have. Okay, so remember, this longer length here is the hypotenuse, which is H. Okay, this is the angle here, so this is the angle, and this will be represented by this letter theta. Okay, so it's this angle here. And what we can say then is that the opposite is always opposite the angle that we have. Okay, so the opposite is going to be opposite this angle. So it's going to be, in this case, it's going to be O. So this is going to be the opposite. So we have the hypotenuse, we have the opposite, and then this here is going to be the adjacent. And it doesn't give us a value for the adjacent. So what we can see is that we are dealing with these two guys here. Okay, so we're dealing with the hypotenuse, and we're dealing with the opposite. So we look at our formulas, so we look at these guys here, and we see which one of these has in it the two lengths that we have. So in this case, they're the two lengths that we're interested in. In this case, we're interested in hypotenuse and opposite. So if we look at these, the only one of these formulas that has opposite and hypotenuse is the sine. So sine of the angle is equal to opposite over hypotenuse. So this here is the formula then that we use. So we use this formula. So what we can do is we can write out the formula. So the sine of the angle is equal to the length, its opposite length, divided by the hypotenuse of the triangle. So we can look at this and we can identify what we have. So we can see here that the hypotenuse is equal to 11. So h is equal to 11. We have the opposite, which is the unknown, which is what we're trying to work out. So the opposite is equal to x, and that's what we're trying to find out. And then we can see that the angle is 67 degrees. So the angle, or theta, is equal to 67 degrees. So that's the first thing. Now what we want to do is we want to take these values and substitute them into the formula that we have and work out the value. So it's going to be the sine of theta. So remember, theta is this angle here, which is 67 degrees. So 60, just run this out. So 67 degrees. So sine theta is equal to the opposite, which is x, which is what we're trying to find, divided by the hypotenuse, which is 11, like so. So we have to work out what is x. So the first thing we want to do is we want to, first of all, so in this case what we want to do is we want to now work out what x is. So we have to start getting rid of everything around x, just like we've done with the algebra. So the first thing you want to do is you want to get the sine of 67 degrees. So the sine of 67 degrees. So we can use our calculator to do that. So if we have a look on our calculator, we have here, okay, so we've tan, cos, and sine. So all we have to do is just type, so hit sine, okay, and then put in our angle, which is 67 degrees, okay, and you can close your bracket, and that's equal to 0.92, okay, so it's equal to 0.92. So sine is 0.92 is equal to x over 11, okay. So now what we want to do is we have an algebra fraction here, so we want to get rid of this fraction and we want to work out what x is. So in order to get rid of the fraction, we have to, so this is x divided by 11, so we're going to have to multiply both sides by 11. So you can do it like this. So I want to multiply this side by 11 and I want to multiply this side by 11. Okay, so what's going to happen is this 11 will cancel out with this, and that will just leave us with x is equal to, so 0.9 multiplied by 9.2, so 0.92 multiplied by 11 is equal to 10.12, okay, and we can just round it up to 10.13, okay, so 10.13, okay, so x then is equal to 10.13. So this length here is equal to 10.13. So again, we can look at our triangle, identify the hypotenuse, the adjacent, and the opposite. The opposite side is always going to be opposite to the angle that we have. Identify which of these that we're dealing with. Is it cos, is it sine, or is it tan? In this case, it's sine, because we have the opposite and we have the hypotenuse. Write out your formula, plug your values into your formula, and then solve for x. So that's the first one. So let's have a look at this example here. So in this example, so again, the first thing you want to do is you want to identify what you have, okay? So we identify the hypotenuse. So this here is going to be the hypotenuse. Always the longest side is the hypotenuse. We have this angle here, so the opposite is always opposite the angle that we're interested in. So this side is going to be the opposite side. And then if this is the opposite side, then this side here is the adjacent side. Okay, so in this case, the unknown is the angle here. So we're trying to work out what the angle is. So again, remember, it can be used to work out an angle. Okay, these formulas. So the first thing we want to do then is identify what we have. So we have the adjacent and we have the opposite. So we look at this and we think, like, which one of these formulas deals with the opposite and the adjacent. So we have this one here. So the tan of an angle is equal to the opposite divided by the adjacent. Okay, so we have the opposite and we have the adjacent. We're trying to work out this here. We're trying to work out what the angle is. So we write out our formula. So the tan of an angle is equal to the opposite divided by the adjacent. And then we identify what we have from the question. So the opposite is equal to 10. The adjacent is equal to 7. Okay, and the angle here is equal to, that's what we're trying to work out, what the angle is. So we take our values and we can substitute them into the formula. So we just write it out. So the tan of the angle, okay, so we're trying to work out what this angle is equal to the opposite, which is 10, divided by the adjacent, which is 7. Okay, and we want to work this out. So tan of the angle is equal to 10 divided by 7. So 10 divided by 7. So 10 divided by 7 is equal to, let me change that. So 1.42, let's say 1.43. So it's equal to 1.43. Now what we want to do is we want to get rid of this tan here. All we're interested in getting is the angle. So we're interested in this, just this here. So we have to get rid of tan in front of it. Now in order to get rid of tan, we do what's known as the anti-tan. So we anti-tan this side, so tan minus 1, and then we have to get tan minus 1 of this side, of this number here, which is 1.43. Now if we want to work out what the anti-tan is, so we look at this here. So the anti-tan basically is, so if we take tan, then we have this second function here, so the anti-tan. So what we're saying is that this angle here is going to be equal. So the angle, so this tan will cancel out with this anti-tan. So the angle then is equal to the anti-tan of 1.43. So we just go in here, and in order to get access to this anti-tan, we can see it's in, like, it's a second function. So we just hit shift. So let me just clear these first. So we hit shift, we hit this button here, and we'll get this anti-tan. See, it has a negative symbol, and then we can just put in our value here. So 1.43. So 1.43, and then we can close the bracket. And that's equal to 55.03. So it's equal to 55.03 degrees. So what we can say then is that this angle here, which is what it's asking us to work out, is equal to 55.03 degrees. So again, you just have to be comfortable with understanding how to get rid of. So if it's sine or if it's cos that's in here and you need to get rid of it, you just do the anti-sine, anti-cos, or anti-tan. And again, these guys are on, so you have sine, cos, and tan, and then you have the antis of those, which are the second functions, and you access them by pressing shift on your calculator. So again, in this case, we were asked to work out what the angle is in the triangle given two sides. So we first of all identify the parts of the triangle, hypotenuse, opposite, and adjacent, identify what we have. So in this case we had opposite we had opposite and adjacent, look at which formula we're using. So tan deals with opposite and adjacent. Write out our formula, write in the values that we have from the question, and then work out and solve for the unknown, which in this case the unknown was the angle, and work out what the angle is. Okay, so that's that one. Okay, so just finally we'll have a look at this one. So again, we look at our, so in this case the unknown is this value here, which is x. So we're trying to work out what the length is of this side. So in this case we're trying to work out length. So we're trying to work out a length. So it gives us, like this is the unknown, it gives us one of the lengths and it gives us the angle. So again, remember the longest side is the hypotenuse. So that's what we're trying to work out. Let me put that in red actually. So hypotenuse. If the angle is theta, remember the angle that we have or that we're trying to work out is theta, which is the symbol. If this is the angle, then this side here has to be the opposite. So remember that the opposite is opposite the angle that we have or that we're trying to work out. And then if this is the opposite, this is the hypotenuse, then this here is the adjacent. So again, we try and identify which of these three formulas do we use. So we're looking for hypotenuse, we have an angle, and we have the opposite. So we have hypotenuse and opposite. So we have a look at this and we see which of these formulas do we use. So we're looking for the hypotenuse and we have the opposite. So which one has opposite and hypotenuse? It's this one here. So it has opposite and hypotenuse. So again, we write out our formula. So the sine of the angle is equal to the opposite divided by the hypotenuse. Okay, so it looks something like that. We identify what we have. So the angle is equal to 65 degrees. The hypotenuse is unknown, okay, and they've just called it x. The opposite is equal to 12, so the opposite is equal to 12. Okay, so then we take these values and we substitute them into our formula, and then we solve for the unknown. So the sine, so sine 65 is equal to opposite, which is 12, divided by the unknown, which is x. Okay, so it looks something like that. So we work out, so again, we just get sine 65 here. So we can use our calculator just to work that out. Okay, so sine 65. So sine 65 is equal to 0.91. So 0.91 is equal to 12 over x. Okay, so it looks something like that. And now we'll just draw lines here on both sides. So we're trying to work out what x is, and we have to get rid of this fraction. So in order to get rid of x on this side, we have to multiply both sides by x. So I have to, if you like, multiply this by x, and then multiply this side by x as well. So x by 0.92 will give 0.91x is equal to this x, will cancel out with this x, is equal to 12. And now what we can do is we can divide both sides by 0.91. So divide this by 0.91 and divide this by 0.91. And then x is going to be equal to 12 divided by 0.91, which will give us 13.24. So 13.24. Okay. And that, so this length here, the length of this side is equal to 13.24. Okay, so that is trigonometric ratios, and using these trigonometric formulas to work out you're either trying to work out an angle, an unknown angle, or an unknown length. Okay, thank you for listening.